Welcome to Bitunet Code channel. So guys, let's continue our CCNP series, and today we'll discuss about VLANs, right? So in the last session we had discussed about frame forwarding, and from today we will check what are VLANs and why do we need to create VLANs. Guys, what happens basically at layer 2, MAC addresses are forwarded to all the switches, right? So to reduce that broadcast of MAC addresses, right, we divide the networks at layer 2 into different segments. So we use VLAN to reduce that broadcast cast domain size. So VLANs are created to reduce the broadcast domain size so that one user from one VLAN cannot send broadcast to different VLAN, right? So we can create VLANs based on any logic like based on department or based on the permission criteria. And guys, in case you have noticed that I have started putting watermarks in my videos because I have noticed that my videos are being copied and data is being used by different websites. So I'm not going to take the name of that website where I have noticed that my videos are being copied, but I'm using my watermark to avoid that, right? In case anybody uses my videos on their websites. So let's go ahead with our topic, VLANs. So by default, all switch ports belong to a single broadcast domain, right? So whenever any switch and any user that is connected to a switch, he sends the broadcast. That broadcast will go to every port, every user, every device that is connected to switch. So to control that, we use VLANs. We create multiple broadcast domains on switch with the help of VLANs. So VLAN is also used for device virtualization. And guys, in frames we have bits reserved for VLAN, and that are 12 bits that are reserved for VLAN ID. So 2 raised to power 12 is equal to 4096. So that's why we can create 4096 VLANs, and out of which 1 to 1001 are the standard, and 1002 to 5 are extended, and 1006 to 4094 are extended VLANs. And the commands that we can use to check the VLANs and layer 2 information, we will shortly discuss those commands also. Let me go to next slide. And I think I already told you in my previous video that what are standard VLANs and extended VLANs. So we are not going to repeat that today. And guys, we have VLANs of two types. One is local VLAN, where VLANs are limited to single switch, and end-to-end VLAN, where VLANs are not limited to single switch, but rather than they may be connected to different switches, and they are called end-to-end VLANs because those VLANs are available across the enterprise. And guys, access ports are members of a single VLAN. Trunk ports carry data of all the VLANs. That's why whenever we connect a switch to a different switch, we have to make that port as trunk port. And when we connect end devices like users, desktop, laptops, servers, printers to a switch, we connect them to access port. We configure them as access port. And guys, whenever data frame is sent from a switch to other switch, right? If it goes through trunk port, VLAN add is added while sending data on trunk port, and when it is sent on access port, then VLAN tagging is not required. So whenever switch receives a frame from another switch with a tag, then it reads the tag and forwards the that frame to appropriate VLAN only. And if it is for a same VLAN that the switch has, then it forwards that to access port. In case it has to forward to other switch, then switch does not remove the tag and forwards it to next switch. So we will look at that in detail. And we the tagging that we use, that is called encapsulation, and that is of two types. One is called inter-switch link, which is Cisco proprietary. Other is called 802.1q dot 1q, which is open standard. And these days ISL is not used, whereas 802.1q 8.1q is used. And these tags that are added to the Ethernet frame, they carry some information, right? And the size of these tags is 30 bytes for ISL and 4 bytes for dot 1q. ISL is not used these days, but dot 1q is used. So VLAN tagging protocol should be same on both the switches for trunk to work. And guys, here are the details of 4 byte tag that is added by dot 1q. So we will not discuss ISL tagging because anyways that is not used these days. So let's go into detail of 801q tag. uh, it has 4 bytes of tag, and out of which 2 bytes are used for by TPI, that stands for tag protocol identifier, and 2 bytes are used by TCI, that stands for tag control information. And this TPI show keeps the value as 0x8100, right? That shows that the tag that is being used is dot 1q, and TCI has 12 bits, out of which 2 bytes, that means 16 bits, out of which 12 bits is used for VLAN ID, that is in hexadecimal format. 3 bits are used for class of service, and 1 bit is reserved or unused. And these 3 bits are used by class of service, and they have a very important role in this tagging. Let's discuss that also. Guys, whenever we send voice and video data, that is sent over the layer 2, okay, as because that data is a latency critical data, we cannot afford to send that data late, otherwise that will be dropped, or voice is broken, or video will be broken, right? So that is called latency critical data, and it should be sent as soon as possible, as soon as it is received. That's why we enable class of service bit for voice and video data, right? This one in tag control information. So this bit is enabled, and so that this data is prioritized uh, at layer 2. Okay, and this is used in conjunction with quality of service. Quality of service works at layer 3 for video or voice data prioritization, and class of service works at layer 2. So basically, for video and voice data, both these class of service and quality of service, they work in they work in they support each other, and that's so that data can be prioritized. Class of service works at layer 2, quality of service works at layer 3. So they work in conjunction with each other. And now, guys, let's see the switch port status. We have two kind of switch port statuses. And the one is called administrative status, and other is operational status. So let's discuss all this in detail. And for demo practical demonstration today, we will have a look at evng. Right here I have installed evng because there are a lot of commands that are not available in cisco packet and gns. So in ccnp we'll be using evng software. So first of all, let's do one thing. Let me add layer 2 switches, and we will add two layer 2 switches, and let's change the switch icon also. let's click with this one. Okay, here we have two switches, and let's add virtual machines also. So we are going to use VPS. So we'll use four virtual machines. Okay, and let's click on save. Okay, now we have four virtual machines that we will create VLAN, and we will test the switching part. So let me connect these switches to each other. First of all, Ethernet 0 to Ethernet 0, and now let's connect this switch to each of the virtual PCs, and this one also. And let's give the IP address also. So for that we have to start the switches. Let's select all and select start selected, right? Okay, so our machines are started. Okay, there is no IP address configuration. So let me give IP address. We will use 10.0.0 network. Let me write it over here. 10.0.0.0/24 network we are going to use. Okay, so for this machine we will use 10.0.0.1, and for this one we'll use 10.0.0.2, and for this one we will use 10.0.0.3, and for this one we'll use 10.0.0.4. And let's see if we can ping these machines. Right now ping is working, right? Because they all are in same network and same VLAN. Let's test with others also. This is working. 3 4. Okay, so all machines are working properly and able to connect. Now let's take uh, access of switches also, and other switch also. So first of all, what will be, let me do one thing. Let me increase the font size so that it is easily visible to our viewers. Let's go to appearance and change the font size from here. Let me keep it at 12. Apply. Okay, so this should be properly visible, and a change for this one also. First of all, let's change the host name. Let's keep this switch host name as switch 1. Enable conft host name switch 2. Right. Okay. This is the switch version. We can check the operating system and other details. Show interface. Let's see how many interfaces are here. So we have four interfaces, out of which one has become a trunk automatically, right? And let us check here also. Show interfaces status. Okay, and this is also a trunk. Okay, this is auto. So let's check further details. I think the view is not coming clear, so let me do one thing. Let me change the font size and reduce by 1. Let's give this command. Now this is looking better. Okay, so we can see that trunk is automatically created, right? Let's see, go for show interface trunk, and we can see that by default switches are in uh, desirable mode. So this is in trunking. Okay, and this is also in desirable mode. So this encapsulation n shows that this has been negotiated, and ISL encapsulation is being used. We recently checked that uh, there are two kind of encapsulation that is used on switches. One is ISL and other is 802.1Q. And because these are the Cisco devices, so Cisco devices use their own protocol, that is ISL. So if both the devices support ISL, ISL will be used. If one device does not support ISL and other does, then a dot one Q will be used. So now first of all, what we are going to do now, we will check about VLAN. So let me show you that there is no VLAN created over here. Over here also there is no VLAN, right? So what we are going to do, we will use VLAN 10 and 20. So let me add text here, VLAN 10, and put it here. This will also be part of VLAN 10. Let's rename this to VLAN 20. Okay, so we have mentioned the VLAN, and this PC we will keep a part of VLAN 10, and other PC will be part of VLAN 20. And after that we will see if user of VLAN 10 is able to ping user of VLAN 20 or not, right? So let's go to switches and create two VLANs on the both the switches. VLAN 10, VLAN 20, sorry, VLAN 10. Okay, now we have VLAN 10 and VLAN 20 on both the switches. And now also give the membership. We will give PC 3 as a membership of VLAN 10. So let's give membership also at the same time. Guys, the first command that we give while configuring the membership is very important to know. Switch port mode access. This command we give to the on the switch to disable DTP, because by default DTP, that is called dynamic trunking protocol, it runs on all the ports on the switches. So whenever we put any switch port in access mode, right? We know, so usually stop or disable dynamic trunking protocol, so that in case any a user tries to disconnect that PC and connect the switch to that port, he should not be able to trunk. Okay, so we are disabling a DTP on this port by giving switch port mode access command. And now we will tell switch that you have to access switch port access VLAN 10. Exit interface is Ethernet 0/2 switch port mode access to disable trunking, because it is enabled by default on all the ports. As soon as any switch is connected to any port, it starts trunking, right? So on these ports, trunking should be disabled. So, and we are putting them in access mode, switch port mode access command to disable DTP, and switch port access VLAN 20. So VLAN brief. Now we can see that default VLAN we have, that is 1, and there is no port connected to it. Ethernet 2 is part of VLAN 1, but Ethernet 3, sorry, is not connected to anywhere, right? And Ethernet 0 is a trunk port, and Ethernet 1 and 2 are connected to end devices, as we can see over here, right? So same job we will do on switch 2 also. So let me show you the switch 2 console. Conf t. First of all, we'll create VLAN 10, VLAN 20. Let's go to Ethernet 0/1 switch port mode access command to disable DTP. Access VLAN 10 interface Ethernet 0/2 switch port mode access to disable DTP. Switch port mode access, you have to enable access VLAN 20 only, and show VLAN brief. Now we can see that both the ports are part of different VLANs. Now let's see whether these end devices that were able to ping each other earlier, whether they are able to ping now. Let's try this. Show IP. This machine has IP 10.0.0.1, ping 10.0.0.2. Okay, we can see that this time this machine cannot ping, right? Because switches do not forward the frames or data of one VLAN to other VLAN. Now for this VLAN routing, either we need SVI or layer 3 device for inter VLAN routing, or for connection between these VLANs, right? Now let's see a few more important configuration details on the switch. Show interfaces, Ethernet 0/0. Let's switch port. Okay, let's see the layer 2 details of interface 0/0. As we can see that switch port is enabled. This command shows that this port is working as a layer 2 port, right? And administrative mode, we can see that it is dynamic desirable, and operational mode is trunk. This port is trunking, and how this is trunking? It is using ISL, operational trunking encapsulation, and this trunking is happening by negotiation. We can see that negotiation of trunking is on, and administrative native VLAN tagging is enabled. Okay, so these are the details. and rest of the details are not important. So let's see details about layer 2 details about Ethernet 0/1, that is the access port, right? We can see that 0/1 is a access port connected to PC3. So here we can see that switch port is enabled for 0/1, and this has uh, administrative mode and operational mode as static access. These ports are not in trunking mode. By default, they are in trunking mode, but we have configured these ports as access ports. So whenever we change the access mode of administrative mode as a static access, operational also becomes static access. So trunking encapsulation is a negotiate by default, but trunking is not happening at this port. We have disabled that. So this is access port now. Here says negotiation of trunking is off because this is not a trunk port. And access mode VLAN 10, it knows that it is the part of VLAN 10 that is in access mode. Now let me show you what information we get by show interface trunk command. This says that this was in desirable mode, and encapsulation it is using ISL. So what we will do, we will change the encapsulation from ISL to .1q. Let's go to conft interface Ethernet 0/0 switch port. To change the encapsulation, we have to use the switch port command and then trunk. Here we will use encapsulation keyword, and it gives us three options. .1q ISL negotiate. ISL is already enabled, so we will change the encapsulation to .1q. Switch port mode trunk. We can see that here trunk encapsulation is changed and the mode is on, right? This will not negotiate. This will force the trunking, right? And encapsulation will be used at 802.1q. Let's go to other switch and see what is the trunking snail enable. Here we can see that this was we enabled 802.1q, so it automatically negotiated. Here enemies negotiation has happened, right? And negotiation has been done using 802.1q, right? And guys, this is the trunking with the help of VTP. Let's also look at this command also, show VTP status, right? We can see that a VTP version capable, that is 123, whereas the VTP version running is the 1. Domain name, we are not using any domain. Pruning and traps, they are disabled. And this is the device ID. And by default all the servers work in VTP operating mode, that is server, right? We will also see how we can change VTP operation mode from server to transparent or to client, right? And let's have a look at VTP status on switch 1 also. Here also we are getting the same details, and this switch is also in server mode because server mode is the default mode. Let's have a look at DTP status. And by default DTP is used, but we have to send more than one VLAN. Okay, then we use VTP. So these are the default timers for DTP, dynamic trunking protocol. hello packets timer is 30 seconds, and timeout is 300 seconds. So here this is showing that 4 interfaces using DTP, and on switch 1 also uh, there are 4 interfaces that are using DTP. But in reality we have disabled DTP on 2 interfaces, only one is using DTP, right? Now let's see how we can change the switch from VTP server to VTP client or transparent. For that, let's go to conft VTP. Here configure VTP device mode. Okay, here we have three options: client, off, server, or transparent. Guys, if you notice that if you work on Cisco Packet Tracer, we don't get option to turn off VTP, right? Whereas here in EVE-NG we get extra features. So this off option is available here. So now let's this switch. This is switch 2. Let's make it client. VTP mode client. Okay. Show VTP status. Now we can see this. This is the client. Okay. Now what we want, that we want to create one more VLAN. So let's try to create one more VLAN on client and see whether we can create VLANs on client or not. I want to create VLAN 30. It says VTP VLAN configuration not allowed when device is in client mode. So that means I have to go to VTP server to create, change, modify, or delete the VLANs. So let's go to server switch, and here I can create VLAN 30. Show VLAN brief. Okay, here I have one more VLAN 30 created, and let's go to client switch and go here and see do we have VLAN 30 information available here. Not yet, so let's do VLAN brief once again. The VLAN information has not yet reached. So VLAN messages are sent every 300 seconds. We will discuss in detail what are those VLAN messages, and we have to wait for 300 seconds for the VLAN update, VLAN to come, and those VTP messages that are sent by servers to client or transparent are of four kinds. They are VTPs. Let me open MS Paint here. Okay, so the VTP. Let me text box here, and font is really very big, so let's change it to 14. VTP messages. So we have four kind of VTP messages: VTP summary messages, second is VTP subset, advertisement. Let's add advertisement here also, and we have third one for VTP subset. So these are the four kind of VTP messages that are transferred whenever there is communication between servers and clients, right? So guys, now let's have a look at what kind of information is transferred from server to client in through these VTP messages. Let me open CCNP book for you, And guys, these are the commands that we can normally use to create the VLANs and give names to VLANs. We recently used these commands to create VLANs and assign membership of those VLANs, right? So there was something important that I wanted to show you. This dynamic VLAN is created or managed with the help of VMPA server, right? This is not in scope of CCNP, so we are not going to discuss dynamic VLANs. So guys, here we can see that why do we use VLAN? This is actually a Cisco proprietary protocol that is developed by Cisco to manage VLANs across the campus networks, right? And VTP is organized into management domains or areas with common VLAN requirements. And we just discussed that the VTP modes are of three kinds. One is server mode that has full control over VLANs and modification of domains. All VTP information is advertised to other switches in the domain, while all received VTP information is synchronized with the other switches by default. A switch is in VTP server mode. We just saw that, right? Note that each VTP domain must have at least one server so that VLANs can be created, modified, or deleted, and VLAN information can be propagated. VTP clients do not allow the administrator to create, change, or delete any VLANs. Instead, they listen to VTP advertisements from other switches and modify their VLANs configuration accordingly. In effect, this is passive listening mode. Received VTP information is forwarded out trunk links to neighboring switches in the domain. So the switch also acts as a VTP relay, right? Any switches who is in client mode or transparent mode will also act as a VTP relay. Okay, and this is the third mode that is called transparent mode, in which the switch does not participate in VTP advertisement. Okay, while in transparent mode, a switch does not advertise its own VLAN configuration, and it does not synchronize its VLAN database with the received advertisement. In VTP version 1, a transparent mode switch doesn't even relay VTP information it receives to other switches unless its VTP domain names and VTP version numbers match those of other switches. In VTP version 2, transparent switches do forward receive a VTP advertisement of out of their uh, ports acting as VTP relays. So guys, the important thing about a VTP advertisement I wanted to uh, discuss with you is this: VTP advertisement and the kind of advertisements. So first is summary advertisement. VTP domain name server sends a summary advertisement every 300 seconds and every time a VLAN database change occurs. Let me explain you this in MS Paint. Let's create three switches here. Got one, two, three. For example, these are the three switches, right, that are connected to each other. And let us suppose that this is server and this one is transparent and this one is client. Okay, so we can create VLANs only on this server, not on transparent on client. So the server will send the VTP summary advertisement. Let me create that. So server will send here summary advertisement to the transparent server, right? So transparent will hear that summary advertisement and it will forward to a client switch. Now what does this summary advertisement contains, right? It contains this information about version of VLAN that is being used, and some type that is going to be summary advertisement, and number of subset advertisement that will follow, and domain name length. Okay, and here comes the management domain name that we can set like anything like cisco.com or microsoft.com or whatever. Okay, and then the configuration revision number. Basically, the switches update their database based on the configuration revision number. And as soon as the switch notices that it has the highest configuration number, it will update its mm, uh, the VLAN database, right? And there comes the update timestamp, and then we have MD5 digest hash code. So all this information goes in summary advertisement, and after summary advertisement goes subset advertisement. And subset advertisement, here it says that number of subset advertisement to follow, right? Let me explain you more clearly. VTP summary advertisements are sent periodically or on a trigger, right? Or whenever any change happens, right? So what do these summary advertisement contain? They contain VTP version, they contain domain name, they contain configuration revision number, they contain number of follower. That means subset advertisements that are coming. Okay, they also contain the updater ID and then MD5 digest. So this is the information that is followed, sent in summary advertisement, right? So guys, VTP version 1 should be matching, right? Only then this summary advertisement will be accepted by the next switch. Let's see what is the version number. Let me show you. Here we can see that VTP version running is 1, right? So this information will go into the summary advertisement. And domain name, right now we are not using any domain name. Okay, so let's do one thing. Let me configure the domain name in the server switch. So let's see, uh, this is in server mode, right? Switch 1. So uh, let's also have a look at the switch 2 and show you that currently there is no domain name configured on switch 2, and this is a client. So what I am configuring a VTP domain. VTP domain, I am keeping Cisco 123.com. Okay, .com is not required, but if you want, let's keep it a Cisco domain. Okay, so it says that changing domain name from null to Cisco 123. And let's see if the same uh, domain name has come here. Here we can see that domain name came here as Cisco123, right? It immediately copied the uh, VLAN information, VLAN database, and updated its database from the server. Now we can see that currently we have. Let me also show VLAN brief. We can see that we have 3 VLANs created, and this is also part of Cisco 123 domain. Now both these switches will communicate, okay, and the domain name is same, okay, and we can also see that revision number. Let me have let's see if I can see configuration revision, right? We have configuration revision number here too, and let what is the configuration revision number here? Here we have configuration revision number 3. So let's give that command show VTP status once again. So now this also has updated configuration revision number also 3, right? When the change happened, it increased by its revision number from 2 to 3. One change happened, that's why one revision number has been increased, right? So now both have same revision number and same domain name. Okay, now next is the thing that follows in summary advertisement is a number of followers. Number of followers, that is the how many subset advertisements are coming, and then it also shares updater ID. Let's see, do we see updater ID in this? Updater ID is normally the IP address that is lowest IP address used by switch, but in our case we haven't configured any IP address, so this is not visible here. And then we have MD5 digest that is shared. So let's compare this MD5 digest of both the switches. Show VTP status. Show VTP. Okay, now we can see that MD5 digest of both the switches is exactly same, right? That means they have same copy of VTP database with them, right? In case there is anything missing, then the VTP the database will not be shared, right? So we will check that by configuring the password. Now let me do go on server switch, and here I am going to password Cisco. I change the password to Cisco. Okay. Now I have configured the password Cisco, and revision number is 3. Okay. Now let's see if the same information is copied here. We can see that MD5 digest has changed, right? Because this switch does not has the password. This is using null password, and this one is using Cisco password. So there is difference in MD5 digest values. So and right now trunking is not happening. Database is not being shared properly. Okay, so as soon as I will give password, it will copy match the passwords, and then it will update it MD5 digests also. So let me give VTP password here as Cisco. Show VTP status, and now see the VTP status. Now we can see that the MD5 digest value of both the switches has been updated because all the information is same, right? Configuration revision number is same, and domain name is same, and password is also the same. So they have exactly same database of VTP across both the switches. And guys, before we wrap up, let me also tell you what information is sent in subset. Okay, subset advertisement. Let's read this first of all. VTP domain server sends subset advertisement after a VLAN configuration change occurs. These advertisements list the specific changes that have been performed, such as creating or deleting VLAN, suspending or activating a VLAN, changing the name of VLAN. Okay, so This is all the information, and this is the information that is sent in VTP subset advertisement. Okay, so this subset advertisement is always sent along with summary advertisement. So, and guys, let me also tell you one thing, that in the VTP subset VTP, let me write here, maximum 72 VLAN information can go in single subset ad, right? So if we have more than 72 VLANs in our network, so switch will create a next subset, okay, and then it will send those subset to the next switch. So for example, if we have 200 VLANs in our environment, right? So switch will send 1 to 72 VLANs in subset advertisement 1, and 73 to 144 VLAN information in subset advertisement 2. Right, so this way information will be shared, and 145 to 200 VLAN info in subset advertisement 3. So 3 the subset advertisement will be followed after the summary advertisement, right? And in case a new switch, let's suppose our domain has been joined by a new switch, and we have added, let me write here, a new switch has been added into our domain. Okay, not this one. Now I have connected a new switch, right? So this is also client switch. Now the summary advertisement will go to this switch also, and it will check the revision number, and it will say that the summary advertisement has come, but the subset advertisement has not been received to this, because if there is any change in the VTP database, only then subset advertisements are sent, right? So in case this client new switch has not got the updated VTP data, okay, then it can send the VTP subset request to the switch to send the VTP summary advertisement along with the VTP subset advertisement, right? So in normal scenarios, when there is no change, right, switch will keep on sending the summary advertisements only, and they will see that transparent and client switches will see that server has a revision number same as we have, so they will not check any subset advertisement, right? So switch is not required to send any subset advertisement if there is not any change in VLAN database. So now this client check the revision number, it sees that my revision number is 0, whereas the revision number that is coming from the other switches, let's suppose that revision number is 3. So it can give a request to other switches to send the VTP through VTP subset request, right? So then VTP server will send the summary advertisement message and a subset advertisement once again to this new switch, and then it will copy all the new database from the other switch. So this is the reason why we have this different kinds of advertisement. The third one is used by clients to request for database that it lacks, and then we have VTP join. So this VTP join we will discuss in the section VTP pruning, right? So guys, this was the today's session about VLANs and VTPs, and I hope that you like this session. In case you have any questions or comments about this topic, please let me know in comment section, and I will definitely discuss that in next video. So thank you for watching this video. Bye bye.